Hello and welcome back to my channel. So we're getting started on Unit 10, Sequences and Series. This is one of the biggest Unit 10 BC things that we can kind of talk about. And this first part's kind of laying the groundwork for a lot of things. So a sequence is a list of terms that are arranged in a particular order. This can be any kind of list, so it could be something like 3, 5, 7, 9. It's normally a list of numbers separated by a comma to give us a sequence. A sequence can be finite, it has an end, like we have up here, 3, 5, 7, 9, or it can be infinite. So it can go on forever, and we show that by just adding our dot, dot, dot. So this is now an infinite sequence versus here where it's finite. We are going to be dealing with more infinite sequences than we are going to be dealing with finite, but knowing which one's which is kind of helpful. We can name these terms using an index like n or k, kind of like what we did for summation notation. We use the name of the sequence along with its index. So if we have named the sequence, sequence A, sequence F, sequence J, you would do that letter and then sub a number. So if we took the sequence that we had before, so we have 3, 7, 5, 9, and we said this is sequence A, we would say that this first term is A sub 1. It's the first term in sequence A versus A sub 2, A sub 3, A sub 4, and so on. Once we get to here, when we get to that infinite sequence, we can also name this A sub n. And A sub n is generally going to be some sort of rule equation that kind of works along with us. So A sub n is the nth term. Generally, A sub n gives us the ruler formula of any term sequence. The big thing there is that it's called the nth term because it is term n. Okay, on the other hand, a series is the sum of the terms of a sequence. So we're going to be dealing with series more than sequences, but we get a series from the sequence added up. So if we have a sequence of 1/2, 1/4, 1/8, 1/16. This is a sequence versus 1/2 plus 1/4 plus 1/8 plus 1/16. This is a series. So a partial sum is the sum of the first n terms of a series. We may not know what a full sum of the series is, but we might be able to find a partial sum. So sometimes we will look at that. A partial sum is denoted by S, so capital S sub n or S sub whatever. So if I wanted S sub 5, that would be the sum of the first 5 terms. We can have an infinite series converge to a specific value. So we're going to be looking at partial sums to kind of help us make some decisions on what that would be. If we're looking at an infinite series and what it converges to, that's going to equal S a lot of the times, so the full sum. So let's look at a visual representation of that series that I just showed you guys, 1/2, 1/4, 1/8, 1/16. And we're going to do that by looking at the area of some things. So we're going to take a box that is 1 by 1. So this is a 1 by 1. If I want the sum S sub 1, we're going to do half that box. So half of this box is going to be our first area. So all of this here is S sub 1. So we know that equals 1/2. We're going to get to S sub 2. So we have our box again, which still is a 1 by 1. So S sub 2 is 1/2 plus 1/4. So we have 1/2 and 1/4. If we add these two together, we get 3/4. S sub 3, we're going to be adding together 1/2, 1/4, and 1/8. So half of this is our 1/2. Half of the remaining is our 1/4, and half of that is that 1/8. Altogether, that's going to give us 7/8. And the last one that we have on here that we're going to look at for right now is S sub 4. I was really hoping there. So S sub 4, we still have our 1 by 1. S sub 4 is 1/2, 1/4, 1/8, 1/16. So half this box is going to give us the 1/2. Half of that is going to give us the 1/4. Half of that gives us the 1/8. Half of that gives us the 1/16. Altogether, if we add everything together, we're going to get 15/16. So one of the things that we're going to see is that this sequence is every time we get to the next term, we're cutting the last term in half. So we're adding on half of the previous term every time. If we were to do this as we get closer and closer and closer towards infinity, we're going to keep cutting this area in half. So eventually, when we keep cutting this area into half, it's going to get so small that we have pretty much covered the entire area. Well, the entire area of this box is 1, so eventually our series here will converge to 1. And when we say converges to 1, that just means eventually the number that fraction will equal will be so close to 1 that it will be 1. So when we are looking at these things, we look at a summation. So if the sequence of partial sums S sub n has a limit L, then the infinite series converges to that limit. So what we're saying here is if we have a series, which is the sum, in our case probably an infinite series. So A is our series. We have A sub k, which is each term of our series, and we're adding up every single one of those terms with this summation. So the sum of this series, or the sequence, is equal to the limit as n approaches infinity. So this is kind of going back to that idea of a summation. We can kind of go back and forward between a limit. So we can instead say as the limit as our summation is going towards infinity. So as we look at those infinite terms of our sequence, this is going to be the same thing as the limit as we approach infinite terms in our series. So as we add up all of those infinite terms of our sequence, it's the same thing as looking at the infinite of our partial sums. So all of our different partial sums, and that's eventually going to give us an answer L, and that is what we call our sum. Like, this is our sum. So whatever we get for this limit, it's going to equal this very specific value. So if we can find the partial sums and see how they're acting, so like here we had 1/2, 3/4, 7/8, 15/16, eventually we'll have an idea of what's going on with this sequence or the series, and we'll talk about how we can find that number. So when an infinite series converges, we call it the sum, which is S. If the sequence of partial sums diverges, then the infinite series diverges. So what we mean by that is if we aren't seeing a pattern that it's going towards, then we are going to diverge. And if each partial sum is getting bigger and bigger and bigger every single time with no cap, then our whole series is going to diverge.